Good morning, boys and girls. I'm going to go ahead and run through some things to help you navigate through secants, tangents, and angles in your Ingenuity program. I'm going to just briefly go over some vocab for you guys before I give you some practice and hints with some problems within the program. So the first vocabulary word we should be a bit familiar with is tangents, which was previously covered. So a tangent ray or a tangent line, it's intersecting a circle only once. So for example, if I have a tangent line, so the line has two arrows for each of the ends. So this line is only touching the circle at one point. So that is our definition of tangent. A property from a previous section says that a tangent line is perpendicular to the radius at the point of tangency. So it's important to note that your point of tangency is the point where your line touches your circle. A secant ray or line, it intersects a circle at exactly 2 points. So I can draw an example of a secant line there, where we notice that it crosses or intersects our circle at those 2 points. So knowing the difference between a tangent line and a secant line is very important. Touches the circle once or touches the circle twice. A chord is a segment with both endpoints on the circle. So a segment does not have arrows. We start at one point and we navigate to the other side of the circle. So that would be our chord, right? Both endpoints are on the circle. And then an intercepted arc is an arc in the interior of an angle with endpoints that are on the angle. So we can work with something like an inscribed angle from the previous lesson. Inscribed angle has its vertex on the circle. And we can maybe call this inscribed angle, angle ABC. And so the intercepted arc is in the interior, so it has to be on the inside. And the endpoints are also on the circle. So our intercepted arc is arc AC, right? It's inside angle ABC. And the endpoints of the arc are points A and points C. So we would call this, using notation, arc with a curve, A, C. Now a couple formulas that they go over relating the angles and the intercepted arcs for chords, for tangents, and for segments. There's a lot of formulas in this unit. So for the first one that they introduce, they talk about the angles formed by two intersecting chords. So in our diagram, notice we have our two chords, right, that cross each other. And the intersection of these chords do create angle X, right? So the relationship here that they give within the formula, they're presenting you the relationship between angle X and the two intercepted arcs. You guys have arc A and then the arc over here B. So the formula that relates these three components, A, B, and X, is as follows, and both of these formulas represent the same thing. So for X, one way to represent is that we're going to do 1/2 times A plus B, right, where we're taking the sum. That is the exact same thing as the sum of A and B divided by 2. Okay. I usually use the second formula. I just think it's easier to divide by 2 than working with fractions, 1/2 the other. The second formula that they talk about is the angles that are created by a one chord and one tangent. So in our diagram here, our chord, highlight that in yellow for you guys, is again inside the circle. It goes from one point on the circle to another. And then our tangent is the line that is only touching our circle once. So tangent is going to be in green. Notice that you do have angle X created from the chord and the tangent. Then you also have an intercepted arc A. So a formula that relates the relationship between angle X and arc A is again one of these two formulas. They represent the same thing. So for the value of X, we can take 1/2 times the intercepted arc, which is the same thing as taking our intercepted arc and just dividing by 2. So I use the second formula only because division by 2 I think is a little bit easier than worrying about the fraction 1/2. And the last formulas they give you are the angles formed by secants and or tangents. So this formula is really nice because it works with any combination of secants and tangents. If you look at the first diagram, there is one secant line and then another secant line. And they are secants because it touches the circle twice for both. In the middle diagram, we have a tangent and another tangent because those two rays touch the circle once. And then in our last diagram, we have a secant line because it intersects the circle twice, and a tangent because we intersect the circle once. Right? So for all three of these examples, a secant-secant, tangent-tangent, and secant-tangent, you do have intercepted arcs as well as angle X, which is formed from the tangent or the secant lines. Okay. Your formulas that relate the angle with the two intercepted arcs are the formulas on the bottom. Okay. So in order to find X for any of these situations, what we're going to do is take the bigger or larger intercepted arc A. So notice every single diagram has an arc A, right? And that's the bigger arc that is furthest away from angle X. And then we subtract arc B, which is the smaller intercepted arc, or the one that is closer to angle X. And then take that difference and multiply by 1/2 or divide by 2, which represents the same thing. So I usually use this second formula because I like the division by 2. In the diagram, the first one brought up I thought was kind of confusing, so I'll run through how I would solve this. It says find the measures of the numbered angles. And we are going to go ahead and do this in order, starting with angle 1, which is right here at the top. So notice that angle 1 is created from two intersecting chords. Okay. So we go back to that first formula that talks about the chord with the two intercepted arcs. Okay. The intercepted arcs that we would relate back to angle 1 are the 46 degrees and the 108 degrees. So if we follow our formula for two arcs, the measure of angle 1 should be the sum of both arcs divided by 2. Okay, so sum of both arcs divided by 2. When we add together 108 is 46, we get 154. And then divide that by 2, we end up with 77. Okay, so that would be the measure of our angle 1. Angle 2, notice, is right next to angle 1 on a straight line. So angle 1 and angle 2 are a linear pair. So as discussed, semester 1 of geometry, a linear pair is supplementary and they add up to 180 degrees. So to find the measure of angle 2, we will take 180 degrees and subtract what we know to be angle 1. Okay. So 180 minus 77 gives us 103 degrees. Right, angle 3. So notice angle 3 is an angle outside of the circle. Okay, it is created from 2 secant lines. So we would go back to that last page where we went over the secant angle relationship. Angle 3 has 2 intercepted arcs. We have the larger arc on the outside, which is 108, and then the smaller arc on the inside, which is 34. So if we use our formula from that last page for the secant angle relationship, we take the larger arc minus the smaller arc and divide that by 2. Okay, big minus small divided by 2. 74 divided by 2 gives us 37. Right, angle 4. So notice that angle 4 is an inscribed angle. Its vertex is on the circle. And the inscribed angle opens up to our arc over here. But notice that we don't know one part of this arc. We have 34 degrees, but we don't have the rest of it at the end. There are 360 degrees in a circle, so what we can do is subtract all these other outside arcs from 360 to figure out that missing piece. So our measure, a question mark, 360 minus 108 minus 72 minus 46 minus 34. Right, so again, that's our last arc, and that's why we're able to subtract all of that from 360. And when we do the subtraction, we end up with 100 degrees. So the inscribed angle is always half of the arc that it opens up to. So our measure of angle 4 is going to be the arc divided by 2, which gives us 50 degrees. Okay, our last angle, angle 5, notice that they have angle 5 marked with 2 red curves. Angle 5 is representing this whole angle. And notice that that whole angle is inside a triangle. So within that triangle, angle 3, angle 4, and angle 5 are what create the measures for it. So we go back to the triangle sum theorem from semester 1. Okay, all angles in a triangle add up to 180 degrees. So we can subtract or take away our angle 3, subtract our angle 4, and then we'll be left with angle 5. So our angle 3 we said was 37. Angle 4 we said was 50. So when we take 180 minus 37 minus 50, we end up with 93 degrees. So this problem includes a lot of those relationships, our chord-chord relationship, the secant-secant relationship, triangle sum comes back in, and we use that as well. Okay. In the next video, I'm going to go ahead and show you guys a couple hints that might help you with the practice problems for secants, tangents, and angles. And then I hope that gets you through the practice and help with the quiz.